So we have been doing law of sines, and we know that that works in any triangle. So unlike just a regular sine, it doesn't have to be a right triangle. Law of cosines is also applicable in any triangle. There is just a tidbit about triangles. In any triangle, the sum of the lengths of any two sides has to be greater than the length of the remaining side. So this is just a fact that is always true. If you add up any two sides, that will be bigger than the third side. This is just kind of a tidbit that comes into play with this formula. Due to the sake of time, I'm probably not going to prove to you why the law of cosines works, but if anyone is interested, then I will happily do that after our final and show you the whole derivation of it. But the law of sines is very useful, and it works in any triangle. But in order for it to work, you have to have a complete set of information. You have to have an angle and a corresponding side, correct? If we don't, if I don't give you an angle and a side opposite that, then we're unable to use the law of sines. We wouldn't have the information we needed to set up our ratio. That's a situation where you would want to use the law of cosines. So law of cosines has three different versions, depending on if you were looking for side A, B, or C. And so in that, it's kind of like the Pythagorean theorem. And in fact, in the case where C is a right triangle, it does work out to be the Pythagorean theorem. But this allows us to find any side. Let's look at a problem. A surveyor wishes to find the distance between two inaccessible points, A and B, on opposite sides of a lake. Here is point A, here is point B. While standing at point C, she finds that side B is 259 meters, side A is 423 meters, and angle C is 132 degrees, 40 minutes. I want to find side C. All right, everybody with me? When I'm looking at this, law of sines is a great option, but would it work here? No. I am given a side, the angle in between them, and another side. Side angle side, if you go back to your geometry days. In order to use law of sines, I would have to have one of the angles across from those sides. The only angle I have is across from the side I don't know. So then we do law of cosines. The only version I can use is the one that involves angle C. So if you're looking at this, we are going with the third one. C squared equals A squared plus B squared remember, A, B, and C are the sides, minus 2AB cosine of angle C. Tyler, do you need paper and pencil? All right, so we're going to plug in what we have. I don't know side C. Side A is 423 squared. B is 259 squared. Minus 2 times A times B. Cosine of 132 degrees, 40 minutes. Make sure you're in degree mode. Now keep in mind, the side you get is C squared. So to solve for c, we do a square root. Normally we would do plus or minus, but there's no need because the side couldn't be negative here. So c is 628.1 or 628 meters.
Maybe my cosine, like I can put everything but the cosine, and then I try to multiply by the cosine, and I don't know why it got mad about that, but it
Because it's not the entire thing times cosine, just that term.
it got me.
Alright. Is this example okay? Yeah, it is a little bit nicer if we're only looking for one piece in a triangle instead of everything. A little bit shorter.
I saw that look.
Maybe. So, solve triangle ABC, which means find everything. So if I draw a picture. So angle A is 42.3 degrees. Side B is 12.9 meters. Side C is 15.4. So my given information, I gave you the side, angled, side. Did I give you an angle and a side across from it?
No.
No, so we cannot do law of sines. So if I'm going to do law of cosines, what would I find first? Side A. So we can do the A squared equals B squared plus C squared minus 2BC cosine of A. What's wrong?
You know what mine down wrong. Is there a minus on any of the squares plus the
No,
other squares?
it's just always the two squares added together.
Thank you.
You're welcome.
You want us to go to 5 decimal places?
Just don't round until the very end, if you can avoid it. So this one, turns out to be a pretty long thing. And you're welcome. We're doing it all on the calculator anyway. If you want to just go ahead and put the square root of that in, you can. So if we do significant digits, A would be 10.5 meters. All right. From here, if I'm asking you to find everything, now we could do law of sines. We probably don't want to do law of cosines anymore. You want to do law of cosines if you're looking for a side. It's a faster one, but if you're looking for an angle, law of sines is going to be easier. So if I wanted angle B, for instance, we could do A over sine A equals B over sine B. So side A we just found to be 10.5 divided by the sine for 2.3 degrees equals side B 12.9 divided by the sine of B.
It's not very cool. To make us do another triangle. Very uncool, actually.
Okay, so if we think about the fact this means we could have two triangles. Reference angle. If you use sine inverse. Get 55.8 degrees. Okay. So B could be 55.8 degrees, which means then could we find angle C? So 180 minus the 55.8 minus the 42.3, 81.9. Does that track so my smallest angle was angle A, side A was the smallest side. Side C was the biggest side, so angle C has to be the biggest angle. So that all tracks. If we were doing a second triangle, B would be 180 minus the 55.8. And then C turns out to be 13.5. But is this possible? No, because side C is bigger. So that means angle C has to be bigger. So even though there's a possibility of a second triangle, it didn't work. Any questions on that? Let's go to this one.
All sides. It's all sides we can't do. We can.
Oh my
C squared
gosh.
over A squared. I hate it here. I just gotta solve the cosine.
All right. So this time we were given side, side, side. We have 3 sides. Law of sines only works if you have a side angle pair. We don't have any angles, so we can't do that. So we're going to be stuck doing law of cosines. All right, so let's say I just use the first version. So a squared equals b squared plus c squared minus 2bc cosine of a.
First, we just start by dividing cosine.
We want to get everything away from the cosine. So I can subtract over these terms. And then what would you have to do to get cosine by itself? Divide. Include parentheses around everything and just plug it in. So we're going to do that divided by all of this.
Do we include parentheses around the negative on the square or no? Should this go with this?
I would just like parentheses around the entire thing. So you don't need it on every.
But like for the, you don't need it for the square root, or for the squaring?
No, because you're squaring a positive number, so it wouldn't matter.
Oh, yeah, that one.
Alright. So then, what would I do to get angle A? Inverse. And I got my angle A to be 24.7 degrees. So not beautiful, but we got it. Now if I need to find my others, we have options. We have to get another angle. So we could either do this again or we could do law of sines. With law of sines, we have to consider multiple triangles. We don't with law of cosines because cosine is only positive in quadrants 1 and 4. Can you have an angle in quadrant 4? No, that's between 270 and 360, which is bigger than you can have in a triangle. So if you do law of cosines, you're guaranteed to just get one answer. If you have law of sines, you have to consider the possibility of 2 and figure out which one works. So either way is fine.
So we'll only do cosine and you'll only ever have one triangle.
That's true. When it's possible to do law of cosines. Yes. Okay. So if I did this again just for practice, let's say if I wanted angle B. So I could do the B squared equals A squared plus C squared minus 2 A C cosine of B. Okay, when you are plugging this in, you're subtracting over those terms and dividing by the rest. So make sure you're either using the fraction feature on your calculator or do lots of parentheses. So I got my angle B to be 44.5 degrees. And once you have two angles, the third one's easy. You can do 180 minus both.
Would you be okay with us using these numbers then instead of like finding it out as through another law? Because you mentioned how you don't like, rounding errors and stuff like that.
Yeah, on this I'm going to allow it. Oh. Is that okay? So that is all I'm covering from this section for the sake of time. So our assignment, we're just going to do a few to practice. 13. I wonder if I was missing one. I want to do,
I'll try to do this fall.